The Green Apple Award winner is the NJIT Warren Street Village in Newark, New Jersey. The Warren Street Village is a 3-acre mixed-use residential housing complex located in NJIT's campus in downtown Newark, New Jersey. This 214,000 square foot, 6-building complex bounded by Colden Street to the east, Warren Street to the north, and Raymond Boulevard to the southwest adds 500 beds to the university's existing inventory of residential housing. In addition, the $800 million project includes a restaurant, convenience store, and fitness center for the university's community, as well as offices and classrooms in the new Albert Dorman Honors College. We see construction just starting. Reinforcing is in place. The foundations are well underway. The primary structural system for the project utilized panelized stud wall construction and precast concrete floor planks. We see a large concrete placement. Concrete was chosen for the Warren Street Village for its strength, durability, and fire resistance characteristics. The use of precast concrete floor planks and precast stairs also helped the project team meet the accelerated schedule of the project, which was completed in just over 16 months. The project used over 11,000 cubic yards of concrete in the construction of foundations, poured slabs, precast planks, sidewalks, curbs, stairs, and cast stone veneer. The wall panels are going up in this view. The use of concrete will help the project attain LEED credits for the use of recycled and regional content. The Honors Building is completed. Our final picture is of the overall project. The Bridge Merit Award this year is the Route 4 Bridge over Flat Rock Brook. This bridge over Flat Rock Brook services 90,000 vehicles a day with a peak volume of 8,000 vehicles per hour. Running parallel to Route 80, Route 4 cuts through Bergen and Hudson counties and provides a direct link to the George Washington Bridge. Built in 1930, it contains 3 11-foot eastbound lanes and 2 lanes in the shoulder in the westbound direction. The existing bridge superstructure was rated as poor. The bridge really looks in distress. It consisted of a 24-inch cap slab that was doweled at both abutments. The bridge has a width of 99 feet and a span length of 21.6 feet. The superstructure is supported by 2 concrete abutments, which are in good condition with only minor concrete spall repairs required for the areas near abutment seats. It is obvious that the deck needs to be repaired in this photo. A precast solution appeared to be the best method for effecting repairs in a timely manner. Northeast extreme T-beams, normally used for parking structures, were considered because they incorporate the deck and beam in one precast piece. This would significantly speed up construction. Although the beams themselves could be installed rapidly, the closure grout mixture had to attain a strength of 7,000 psi before any load could be placed. This picture shows the beams being set, and it's quite involved. Since the closure pours would not be precast, the set time would be critical in moving work along in order to reopen the highway. Traffic at some point during the curing time frame would be placed on the bridge. The impact on the vehicles on the bridge and the lessening of it as they completed their crossing would create vibration through the green grout. A grout was investigated which could reach 14,000 psi in 48 hours. After analytical review of the strength versus time curve, it was found that the loss of strength from vibrations would not approach 50%. The grout strength would remain 7,000 psi, which was the minimum allowed. The member is being set carefully. This beam is almost in position. The duration from pouring to opening to traffic was only a few hours. An epoxy grout which could reach the strengths that were needed in less than 8 hours and had a high vibration resistance and was VOC compliant and butyl glycide ether free was selected. Bonding had a compressive strength of 8,500 psi in 16 hours. The set time was 1.5 hours. In 1 week, the grout would attain a strength of 13,500 psi. Construction was completed in early 2013. The new precast superstructure system consists of 9 interior next beams and 2 fascia rectangular beams. This complex project was completed on time and on budget with minimal traffic delays by utilizing innovative precast construction and complex traffic control that ensured commuting traffic would flow unhindered. The previously, quote, poor superstructure has now been upgraded with a product that has a design lifespan of a minimum of 40 years, ensuring that this bridge will serve those commuters economically for decades to come. Here is the bridge in the fall. The Commercial Merit Award winner this year is Digital Realty in Piscataway, New Jersey. What is special about a data center? How about two brand new data center buildings located on the same campus and fed by its own on-site substation? It took a highly detailed-oriented contractor to deliver this world-class facility. The new buildings total over 300,000 square feet, which consumed 5,000 cubic yards of concrete from the footings to the raised metal decks, which utilized lightweight concrete and were pumped into place. We see two views of the building. The concrete slab on grade used diamond dowels at the construction joints. A Vibra-Strike screed was used by the crew to start the finishing process. Multiple ride-on finishing machines were then used to finish the top surface of the concrete to meet specifications. Super plasticized mixes were used for all of the slab on grade and lightweight concrete. Each suite within the new structure would have to be modified to accommodate each tenant's storage demands. Raised floors were poured to house the storage data hardware, which is all powered by the on-site utility substation. Tunnels and halls were used for electrical and mechanical equipment. The construction team said it is the most technologically advanced facility they have ever done. We see here another view of the building. The completed project is massive and generates tremendous amounts of data each day. The Dam Merit Award winner is rehabilitation of Lake Nepean Dam in Wantage Township, Sussex County, New Jersey. Lake Nepean Dam was constructed in 1927 for the purpose of impounding a 24-acre recreational lake for this Wantage Township community. Lake Nepean Dam is a Class II significant hazard structure, which means that failure of the dam may result in significant damage to property. The dam is a straight 290-foot long earth-fill embankment with a concrete core wall. The dam has a maximum height of about 26 feet. The spillway consists of an 11-foot long concrete weir. This is a view of the dam before rehabilitation. This is a spillway before the rehabilitation. There were no sidewalls to protect the embankment. Engineering studies indicated that the dam was at significant risk of being overtopped by several feet of water. Overtopping of an earth dam is not acceptable because the water could erode and fail the dam. Such an overtopping event actually occurred at Lake Nepean Dam prior to the dam rehabilitation construction during Hurricane Irene on August 28, 2011. Various alternatives were considered, specifically constructing a new labyrinth spillway, lengthening and rehabilitating the existing spillway, armoring the dam with articulated concrete block, and armoring the dam with reinforced concrete. The conclusion was that armoring the dam with reinforced concrete was the most practical alternative in providing the necessary stability and long-term durability based on the significant depth of overtopping during the design storm event, as well as providing a cost-effective and aesthetically pleasing option. This is the overtopping slab on the left side of the downstream slope. The rehabilitation design addressed the spillway capacity deficiency by means of armoring the dam embankment with a reinforced concrete slab system, thereby allowing the dam to serve as an auxiliary spillway and pass the additional flows without damaging the dam embankment. The entire crest and downstream slope of the embankment were armored with a 6-inch thick reinforced concrete slab. The reinforced concrete slab on the downslope was constructed in approximately 15-foot wide sections at a 3-height 1V slope. This is the partially constructed spillway with reinforced concrete walls. The overtopping slabs are complete. We also see the discharge channel in the foreground and the left abutment parapet in the background. The construction of the new reinforced concrete elements required about 1,100 cubic yards of 4,000 psi concrete. This is the new spillway discharge channel. The use of concrete in constructing the dam armoring provided the client with a cost-effective and aesthetically pleasing rehabilitation project that met stringent New Jersey dam safety standards. The work was completed on time and within budget. The dam owners are looking forward to many more years of service from their rehabilitated dam. What a great transformation from the old dam in this picture. The decorative award goes to Anderson Street Rail Station, Hackensack, New Jersey. This existing train hub, which travels north of Poughkeepsie and east to New York City, was an important means of travel for thousands of passengers. The prior facility was lost due to fire and was closed 4 years ago. This was a major loss to the workforce and travelers. The project, once initiated in July 2013, was designed to provide a beautiful, contemporary facility for future patrons. Concrete was placed to be later, quote, treated to complement the natural stone, wood, and pillars for the project. The concrete is in place and the joints made to contain the specified colors. This area has a feeling of open for easy entry and exit to the train system. The decorative concrete applications had to occur in the winter of December 2013, a record cold year. Another area is ready for treatment. A colored acid stain was specified to complement the adjacent interior design. The acid stain was topically applied in several colors, and beautiful architectural joints were cut to segment between colors. Staining has begun in this photo. The challenge of this project was the outdoor environment and the extreme cold temperatures. Since walls were not yet erected, the project required external heat and temporary tarp enclosures to maintain necessary temperatures for proper application of acid stain and subsequent protective sealers. A range of colors exist in this area. This fast-track application was accomplished during some of the coldest temperatures within a few days. In addition to protection and heat, the concrete needed to be prepared for proper application of the acid stain and sealer. The end result is a unique, aesthetically pleasing rail station floor that provides an uplift in spirit for patrons traveling to work in recreational areas. This is a great shot of the varied colors and patterns. The Educational Merit Award goes to Villa Walsh Academy in Morristown, New Jersey. This 33,000 square foot athletic center provides recreational space for Villa Walsh Academy, an all-girls Catholic school in Morristown, New Jersey. The majority of the school's student population participates in sports. This view is of the completed all-concrete building. The need for a cost-effective, energy-efficient, durable, and yet appealing facility led the design team to search out alternatives that would be attractive and enhance the existing campus of predominantly brick buildings. Through various meetings, the appeal of a tilt-up concrete building and all its offerings of delivery time, design flexibility, and a comprehensive design package would eventually lead to the decision to use this method. This is the building footprint. One of the original designs called for a standard steel framed building with brick veneer walls to match the existing campus vernacular. With significant project challenges, including a difficult site, aggressive schedule, cost concerns, and attention to student safety, the tilt-up building shell provided an appropriate solution. The tilt walls are being set into their location. The tilt walls must be properly braced when they are standing free. The facility includes a full basement, common areas, courts for basketball, volleyball, and lacrosse, as well as other athletic amenities. The durable concrete walls are designed to withstand the abuse from these sports for generations of students to come, as well as provide a superior thermal value. The building is complete and the gym is ready for the athletes. The tilt-up solution was a wonderful choice. It provided a great frame, an attractive exterior with textured paint and slate impressions in the wall panels, as well as a striking entranceway. What a beautiful building. The building used a total of 1,600 cubic yards of 4,000 psi concrete. All the concrete had excellent workability that resulted in these very smooth tilt walls. Our finished look is at the building at night. Great design plus an excellent contractor led to great success. The Health Services Merit Award winner goes to the Ocean Medical Center, Herrera and Anna Hovnanian Emergency Care Center in Brick Township, New Jersey. In the spring of 2012, Ocean Medical Center, located in Brick, New Jersey, began its $82 million undertaking, the largest expansion in the hospital's 30-year history. A portion of the expansion is shown. The original square footage of their emergency room was in the vicinity of 8,000 square feet, and upon completion of the addition would grow to 46,000 square feet, nearly 6 times its original capacity. The Herrera and Anna Hovnanian Emergency Care Center would consist of a 139,000 square foot addition, encompassing a ground level floor as well as 4 floors above grade. This is the far end of the addition. Concrete was a choice from the footings and foundation walls to the slab on grade, as well as the 4 elevated slabs. Concrete was also used for a large retaining wall to allow for a lower level ramp and loading dock. The engineers made it a point to be as environmentally considerate as possible when it came to the design of the concrete mixes. Fly ash was used to replace a portion of the Portland cement in various mixes on this project, making them more environmentally friendly and reduced the carbon footprint. The fly ash mixes gave the contractor a little more working time during the hot temperatures experienced throughout the pours. This view shows the upper and lower levels of construction. 11,000 cubic yards of concrete were poured to complete the Herrera and Anna Hovnanian Emergency Care Center. This is a view of the cantilevered wall. This building highlights the first signs that the concrete world is becoming greener. Our final view shows the completed structure, which is 6 times larger than the original emergency room. The high-rise Merit Award winner is the Modern in Fort Lee, New Jersey. Set above the Palisades overlooking the George Washington Bridge and the Hudson River, the Modern is a 47-story luxury residential development in Fort Lee, New Jersey. Concrete met the need of restricting the building height in order to keep construction costs within budget, but also preserve the architect's vision of a tall, slender tower. The concrete floor framing system for the building utilized 8-inch flat plate construction, allowing for low floor-to-floor heights while also maintaining a 9-foot clear dimension in the residential apartments. This helped reduce the overall building height and maintained a low overall cost for the building's superstructure. Additionally, the use of concrete construction with concrete shear walls around the elevator and stair cores was the most efficient means to resist the high wind loads from the Hudson River. Using concrete flat plate construction also allowed the structural engineer and the architect to locate columns at opportune locations within the residential apartments, such as within closets and walls, without significantly impacting the quality of the apartment layouts. This is a site with construction well underway. High-strength 10,000 psi concrete was used in the lower 12 floors of the tower, and 8,000 psi concrete was used for floors 13 to 24 to help minimize the column and shear wall dimensions and provide lateral stiffness for the building. The mix design includes superplasticizer, silica fume, and a hydration controlling admixture to maintain slump and workability. Innovative aspects of this project included the use of high-strength grade 97 vertical reinforcement in the building's shear walls and the use of grade 80 longitudinal bars and welded grid transverse reinforcement in the building's link beams. This is a view of that reinforcement. The use of 2.5-inch grade 97 vertical reinforcement in the shear walls allowed the construction of 1-story tall vertical reinforcement cages to be fabricated off-site, picked into place by the tower crane and spliced to the lower lift of vertical bars with threaded couplers. The large diameter bars also reduced congestion typically encountered at the ends of shear walls and allowed for easy concrete placement and consolidation at these locations. This is a close-up view of the link beams with all the reinforcement in place. The use of longitudinal bars and transverse reinforcement in link beams connecting the shear walls of the elevator and stair courses allowed the beam reinforcing to be fabricated off-site and then picked into place by the tower crane. Utilizing large diameter high-strength bars and shear reinforcement had a significant impact on shortening the overall concrete construction schedule by reducing the amount of field time needed to build these structural elements. The link beam is being lowered into place. This is the ring beam. The design and construction of the concrete backup support for the curtain wall clad parapets, ring beams, and window washing tracks at the top of the building eliminated structural steel elements that were normally used. This would have slowed down the completion of the tower. Here we see the building well underway. The building superstructure utilized 27,000 cubic yards of high-performance concrete. This building is a great testimonial to superb structural engineering and proper execution in the field. This is the completed 47-story tower. The parking garage merit award winner is Millburn Parking Garage in Millburn Township, New Jersey. The Township of Millburn developed a new commuter parking garage in downtown Millburn. The garage serves nearby business and residents as well as commuters of the adjacent New Jersey Transit Railway stop located in southeastern Essex County. The station services rail traffic from the Morristown line, the Gladstone branch, and is preceded by the Short Hills Station in Short Hills, New Jersey. The design of the parking garage is critical for the township residents who emphasize the desire to minimize the presence of the parking garage as an important factor for the project. The garage is designed for one level of vertical expansion to keep the garage height within an acceptable limit for the residents. The initial precast panels are placed. The garage incorporates a unique facade to keep the scale to a personal level. The stone veneer is visible here. The facade utilizes a stone veneer integral with the precast panels as well as other architectural design elements to complement the unique character of the downtown area. The stone and masonry veneers are visible now. The parking garage is located within a floodplain. The parking garage is exposed to freeze-thaw conditions and de-icing agents as common occurrences. Therefore, durable design measures were necessary for the precast parking garage. Some durable design measures incorporated in this design include 5,000 psi concrete for cast-in-place walls, piers, slab on grade, and precast topping. Mixed design required air entrainment from 5.5% to 7.5%. The project is well underway in this picture. 6,000 psi for precast columns, walls, tees, slabs, beams, and panels. Mixed designs incorporated air contents again from 5.5% to 6.5%. A close-up of the corner veneer shows the precast brick contrast. All cast-in-place toppings contain 3 gallons per cubic yard of corrosion inhibitor as well as 1.5 pounds per cubic yard of microfiber reinforcement. All precast double T's, slabs, and stair landings contain 2 gallons per cubic yard of corrosion inhibitor. All slabs on grade contain 1.5 pounds per cubic yard of microfiber reinforcement. This is a close-up view of the corner. This aesthetically pleasing, durable design of the parking garage will prove valuable in supporting the significant parking needs of the area for many years to come. This is a beautiful completed garage. It is in stark contrast to the multi-cracked asphalt pavement. The Parks Merit Award winner is James J. Braddock Park Playground Improvement, North Bergen, New Jersey. The County of Hudson redesigned the existing playground inside the James J. Braddock Hudson County Park. The design called for new drainage with concrete structures, freestanding seating walls, poured-in-place retaining walls with lining forms, 3 playgrounds with safety surface pavers, a water playground, site furnishings, decorative and chain link fence, reinforced, stamped, colored concrete sidewalks, reinforced concrete sidewalks, TerraWalk and grass pavers, a prefabricated gazebo, and landscaping. We see early slab work. Slabs are now progressing. The freestanding seating walls were created in a horseshoe pattern to match the pattern created with a color concrete band. The walls were built with concrete block. The poured-in-place retaining walls separate the playground from the active to passive areas. The lining selected gave the appearance of a concrete block wall. The combination of gray concrete and red stamped concrete indicates the variety of colors that are yet to come. A new slab has just been finished. The stamped colored concrete serves to highlight areas such as the water playground, hopscotch areas, prefabricated gazebo, and the games tables. The stamped colored concrete also greets the public as they enter the playground. The color selected was Canyon Red. The stamp selected was used brick in a herringbone pattern. This great design has been well executed. The lawn area was seated and delineated with a flush concrete curb. Concrete work is excellent. White oaks create a corridor down the middle of the park for patrons to walk through. The tree pits were built with grass pavers. The tree pits connect to each other via a band of TerraWalk pavers built between the concrete sidewalks. The gazebo is in place and visitors are enjoying it and the surrounding concrete. The other end of the park is an open play area. Water is flowing and the project is complete. Our final shot is the play area where climbing and slides provide the fun. This is a great design that was well executed. People will stand in line to get into this playground. The Pavement Award winner this year is Campbell Freight in South Brunswick, New Jersey. This 90,000 square foot building and 350,000 square feet of parking are all concrete, but not by choice. This is Disney World for the trucking industry. From the 17,000 square foot parts department to the 13 bays capable of handling upwards of 40 trucks at any given time. One section of the interior slab on grade is also designed for steam cleaning trucks. Customer service? How about a wish list that added 3 dining areas and a customer lounge more like a 5-star hotel? Customers can also take the advantage of the free spa-like shower and on-site laundry amenities while their equipment is being serviced. Concrete is the foundation that enabled all of this to happen. The parking lot is what really makes the project special for the concrete industry. Due to the heavy truck volume Campbell Freight deals with, their parking lots are generally maintenance nightmares and plagued with pothole repairs. Owner Scott Campbell never believed it was financially feasible to do paving and concrete. The ready-mix producer supplying the building approached Scott to hand in a concrete bid as an alternate to asphalt and prove that it is possible. The building was design-built, so it allowed for value engineering as the project progressed. The initial parking lot specification was 4-inch aggregate base, 2.5-inch asphalt base course, and a 1.5-inch asphalt surface course. The concrete producer point man for paving leapt into the fray. He proposed an upgrade of 5-inch aggregate base and 6 inches of high-performance concrete. This mix was very similar to the interior slab on grade, i.e. 1.5-inch top size and optimum cementitious content, except that the paving mix was Aaron trained. The key to the successful installation was the 3D Profiler laser screed. The 3D Profiler laser screed automates the very labor-intensive process of concrete installation. It also allows for the concrete parking lot to have 3D contours for drainage. Pour sizes ranging between 500 and 800 cubic yards per hour at up to 120 feet wide. To dramatically reduce labor costs and have a stronger pavement surface, the concrete contractor aimed to touch the concrete as little as possible. Once the 3D laser screed placed the concrete to the desired elevation, it was followed by bull floating and then a broom textured finish. The construction design, correct joint spacing, aggregate interlock, and all took advantage of the concrete mix design's 650 psi flexural strength for load transfer from panel to panel, as opposed to asphalt's immediate direct downward pressure. The mix design takes the same philosophy approach as interior slabs on grade in that we wanted a well-graded aggregate content, number 467, and low water content, low paste content to minimize shrinkage and cracks. This is important as the pavement operates at peak performance and will confidently withstand freeze-thaw cycles and de-icing salts. The parking lot is one of the most important structural features of Scott Campbell's new corporate headquarters. He was on site for every pour, and some started as early as 1 a.m. to avoid the summer heat. This was a great transformation from an old-fashioned asphalt paving approach to the 21st century approach of high-performance concrete paving. The Recreation Merit Award winner is New Meadowlands Racetrack, Rutherford, New Jersey. The Meadowlands Racetrack is a horse racing track at the Meadowlands Sports Complex in Rutherford, New Jersey. The new $88 million Meadowlands Racetrack opened on November 23, 2013, 37 years after the debut of the old grandstands. The new building is 180,000 square feet, about a third of the size of the old one, and is located on the other side of the 1-mile oval track. Its grandstand can seat 2,200, and the clubhouse, simulcasting areas, bars, upscale restaurants, skyboxes, corporate meeting rooms, and outdoor terrace can hold 10,000 people. It also has a 9,000 square foot rooftop deck with views of the New York skyline. The new facility is a steel and concrete superstructure supported by piles. Foundation concrete is underway. Total concrete placed on the project was 7,500 cubic yards and used in various applications. Construction is well underway in this photo. Structural steel members were utilized for the structure. The slab on grade used macrosynthetic fibers at a dosage of 3 pounds per cubic yard and 5,000 psi non-air entrained concrete in grade beams and slab on grade, thus reducing cracking. Deck slabs were poured using 4,000 psi lightweight concrete. A steel deck is installed in this photo. Grandstand seating was formed and poured using 4,000 psi air-entrained concrete and sealed with a water-repellent membrane. The superstructure framing is almost completed and the seating area concrete is started. Interior slabs were both exposed and stained. The building entrance sidewalk utilizes stamped concrete with integral color. The lower seating level is complete in this photo. The new Meadowlands Racetrack hopes to revise horse racing in North Jersey by being a state-of-the-art entertainment center featuring live harness racing, entertainment, dining, events, and family-friendly activities. The completed structure is a beautiful addition to the Meadowlands. The ground-level view is equally pleasing. The Residential Merit Award winner is Meridia Main Station, 534 Main Street, Bound Brook, New Jersey. Meridia is a $30 million apartment complex that is the catalyst for revitalizing downtown Bound Brook. Its purpose is to offer people luxury living at affordable pricing in Bound Brook. This 5-story, 240-unit complex is located on Main Street and is within walking distance to the train. It also offers ground-level parking for residents to house their cars. The foundation is extensive and massive. Over 60 columns support the transfer slab that was poured 16 inches thick using 5,000 psi superplasticized concrete. We see the underside of the transfer slab. Over 60 columns support it. 5,000 plus yards of concrete were consumed by this city block long building. The building frame is almost finished. With the influx of new people and more foot traffic for downtown store vendors of Bound Brook, the town's future is looking very promising. This view shows the tremendous impact this structure makes on a small town. This building is a beautiful addition to Bound Brook. The Tilt-Up Merit Award winner is the Wakefern Food Corporation project in Elizabeth, New Jersey. Since it was founded in 1946, Wakefern has become the largest retailer-owned cooperative group of supermarkets in the United States. Wakefern needed to replace, upgrade, and increase storage capacities of their Elizabeth, New Jersey warehouse originally built in the 1950s. They chose to build a 525,000 square foot temperature-controlled warehouse utilizing tilt-up construction. This is a great overview of the project. The new building features 36-foot high ceilings compared to the industry standard of 20 feet, which increased their storage capacity significantly by 58%. The slab on grade will serve as a casting bed for the panels. Tilt-up construction was chosen for a number of reasons: fast construction schedule, durability, aesthetics, high fire resistance, ease of maintenance, and overall savings in construction cost. Tilt-up also helps to reduce operating costs due to the excellent insulating properties of concrete, thus helping to reduce heating and cooling requirements. This is a typical panel ready for concrete. This typical panel is being lifted. Now we see many panels in place. 25,000 cubic yards were used in constructions. Slabs are 8 inches thick, designed with 4,000 psi concrete, containing number 467 blended aggregate with 75 pounds of steel fiber reinforcement and, of course, superplasticizer. This slab is being struck off with a laser screed. Strength averaged in excess of 5,500 psi with minimal shrinkage. The tilt-up panels consisted of 166 panels with an average size being 42 feet by 26 feet, 180,000 square feet of 6-inch concrete paving was placed for dolly pads and loading dock areas. This facility added more than 150 full-time positions and distributes non-perishable food products to ShopRite stores across New Jersey, New York, Connecticut, Delaware, and Maryland. This massive structure is complete, and it was a great use of concrete.